Hello everyone. This is a video lecture for College Algebra Math 1414 Section 10.1 Ellipses. And so we're going to be talking about conics in Chapter 10. This is a brand new chapter for this class. The homework goes 10.3, 10.1, 10.2. I'm going to be teaching it 10.1, 10.2, 10.3 regardless though. It's all the same content. So let's get started. 10.1 is ellipses. So ellipses are kind of like circles, but not perfect. They're elongated on one side or another. And all of the ones that we're going to be focusing on today are centered at 0, 0. Thankfully, it makes it a lot easier. So the two formulas we have is x squared over major squared plus y squared over minor squared plus or is equal to 1, or the reverse, x squared divided by minor squared plus y squared over major squared is equal to 1. So when I'm saying major and minor, what I'm trying to say is a distance. Major distance is the bigger distance, while minor is the smaller distance. You can see in this particular case, my bigger distance is a y value, so that's what with the y is major. Rather than here, this little distance is going to be smaller, the minor, which is associated with x. And those are the two different varieties. You can use the capital M and little m if you like. I might do that as I keep going for speed's sake. But in the end, major means bigger. I'm going to write it with a capital bigger. And minor is smaller. And that's ultimately what it comes down to, bigger, smaller. I know that the book and the homework and stuff will use A and B and B and A and all that stuff. It's just very confusing. I don't like that. It's too ambiguous. And so I'm going to say major. When you look at major versus a minor, doesn't it look bigger? Doesn't it seem like this is smaller? That's my point. So there's one last formula for all this stuff. It's the formula for the foci, which is plural for focus. So like focuses, I guess? I don't know. Foci, that's correct. It's not focuses. So the formula is c squared is equal to major squared minus the minor squared. Always. And so you have these two numbers from your equation. You plug them in, you get c, and your foci are in particular located at plus or minus c comma 0 or 0 comma plus or minus c. It kind of depends on the x major or a y major. And what are foci? Basically, they are these dots on the inside, which kind of determine how the shape is. If you had a circle, the focus would be exactly in the center. And so as you elongate it on sides, you split them up. And, well, there you go. Okay, let's get some problems done. So we have 10.1.1 is x squared over 25 plus y squared over 4 is equal to 1. And they say graph it. This is actually pretty easy. I'm going to liken this to a 5 squared and a 2 squared. See how I'm just reducing that down, I guess, or I guess simplifying it so that we could see this is the bigger number. And so that's going to be my major. Notice that it's associated with x. So that's going to be an x major. Just going to remind myself of that, equal to 5. This 2 right here is smaller. And so that's going to be my minor because it's smaller, 2. And notice that it's associated with y, so it's a y minor. So x major means that it's going to be this way instead of the other way, up and down. And so all I'm going to do is count out 5 and 2 and toss it all in, and there's my answer. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 1, 2. Notice 5 in my x's, 2's for my y's. I connect them, and there's my ellipse. It's not perfect, of course, but you're getting the idea at least. Awesome. Well, they want one other thing is the foci. They're always going to be asking for the foci. And so c squared is equal to the major squared minus the minor squared. I have those numbers. That's going to be a 5 squared minus the 2 squared. And it's funny because you could have just taken the original denominators. You don't have to always write this. You could just go immediately 25 and 4, 25 and 4. and that would make a 21. So c squared is equal to 21. So to solve for c, you square root both sides and get a square root of 21. Notice, though, that when you square root both sides, you definitely have to have a plus and a minus, and that's kind of why the answer ends up being this way. And so notice that this is an x major, and so it's going to be foci along the x values, something like over there, let's say. And so our y values are 0, but our x values have, numbers. And so we're going to say square root of 21. Those are my x values, and my y values are 0. Again, x comma y points, I guess you can say. Those are my foci. We're going to be doing that a lot, so, and I'm going a little bit fast right now, but again, you could pause, you can slow it down. That's kind of the beauty of a recording. 10(1)(3). I have x squared over 16 plus y squared over 81 is equal to 1. So you can see here that we have a minor. This is going to be an x minor because it's smaller, and that number is going to be a 4. We have a y major, again, because it's bigger, and if you do the square root of that, you're going to get a 9. So we got a 4 and a 9, and what I'm going to do is find the foci immediately, and then I'm going to start graphing it in just a second. So c squared is going to be equal to the 9 squared minus the 4 squared. Or again, you could just immediately put in your 81 minus 16. That's okay as well. I got 65, and so then when you square root both sides, you get the square root of 65, and because it's the y major, your foci are going to be along the y axis, and so you're going to be putting them as 0 for x and y values from your c. And so let's graph all this together and see what we're going to get. I have basically 9 for my y's. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And I got 4 for x. 1, 2, 3, 4, 2, 3, 4. And then I connect them something kind of like this here. Again, it's not perfect. I'm just kind of getting it down. My foci, if you see, this is basically the square root of 64, which is around 8. So it's around 8.1 or so. So you're going to see those about right there. Those are foci right there. Again, I'm not drawing it perfect, but the math is good, and that's what counts. Next question. So 10(1)(11). We have x squared is equal to 1 minus 9y squared. I wanted to do this one just because it's not in a standard format. I'm going to move that over to the other side. So now we have our equals 1. But notice that I need division, right? And so I'm going to create a 1 squared in the bottom there. Basically, what is this divided by? Well, 1. And so what is 1 is equal to 1 squared, basically? Whatever you want to do, just make sure you have a number there that makes sense. But this is the weird part. To get a fraction, I've got to divide by 1/9. And I know that seems really weird, but if you take that and flip it to the top, you would eventually get what we just had a second ago. So that 1/9 is actually a 1/3 squared. And now you can see that this 1 is actually the major because it's bigger. And here we got a y minor because that 1/3 is smaller. To solve for c, we have our 1 squared minus the 1/3 squared. That's 1 minus a 9th is 8/9. And so if you square root both sides, you get square root of 8 over 3. They're not going to accept that as an answer. What they want instead is 2 square root 2 over 3. And that's kind of sad. It's just super simplified. Later on, as you move on into calculus and pre-calculus and stuff, you won't have to do this simplification anymore. Just because we're in my math lab right now, you still have to do it. And so here we go. Again, x major means we're going to have x values here. So 2 square root 2 all over 3 comma 0. This is what they want for the foci. And then when we graph it, we could say 1 for my x, so I'm going to make it a little bit bigger, and 1/3 for my y. It's going to be about right here. There we go. Again, definitely not perfect, but there's some foci for you. Ta-da! Next question. I think what I was wanting to do with a lot of these is, yes, practice them, and that's good, but you can see it's very repetitive. The main purpose of the upcoming ones is that they change one little aspect of it, like this one. Notice that I have a 1,200 something or other over on this side. And so Instead, I'm going to divide this on both sides, and I'm going to get on this side a 16, and on this side an 81. Now it's equal to 1. I needed a 1 there for that format, that style that makes it work. Notice again that we have an x minor, that's a 4. 4. Okay. And I have an a y major, that's a 9. And basically we get the same thing as last time, square root 65, because it's a y major though. We're going to put it in the y values. There you go. And like we just had one of these, there's the error answer. The main idea though is that if you don't have a 1, you need to divide it to the other side to get a 1. That was the reason I did the problem. And now the next problem. I like to do different problems whenever possible, trying to change it up and make sure you see every possibility that you'll have on your homework. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3. And this is a pre-drawn ellipse for you, and they want the equation now. So this is easy actually. If you notice that this is going to be a 4 distance here, right? So that's an x distance of 4. We got a y distance of 3. So which one's the bigger one? It's the 4. 4 is our major. It's an x major, while the 3 is a smaller one, so it's a y minor. And so then you can just go ahead and put it in here. 4 squared, 3 squared. There's your answer. Now, of course, my math lab's going to want you to simplify. So make sure to write it like that. And you're done. They also want the foci every single time. And so c squared is going to be equal to, again, the major squared minus the minor squared, just as a reminder. And so we got my 16 minus 9, to just make it quick, so you get 7. So c is equal to square root 7. And so your foci, again, on an x major means it's going to be the x values, square root 7, and then a 0. There's your foci. All right, another one, 10, 1, 27. So they give me the foci at 0, -3 and 0, +3. Notice that they have that plus and minus business too. The vertices are located at -11 and +11. Notice that all of these are y values. And so I already know that I have a y major. It's a y major whenever you have these vertices here. What are vertices? Basically, they're the endpoints to an ellipse. I didn't mention them, I guess you can say, but there you go. They're the endpoints. Foci are going to be on the inside there. But everything's going to be along this y-axis, and so that's going to be a y major for sure. And because those are the endpoints, your y major is going to be an 11. Your c is going to be equal to 3. And so we can solve that equation to find the minor. I have 3 squared is equal to 11 squared minus the minor squared. That's my minor. And then solve. So I'm going to move this over, move that back over. My minor squared is going to be 11 squared minus 3 squared. That's 121 minus 9. And so I've got 112. So my minor squared, I'm going to write it out. My minor squared, this is an x minor, is equal to 112. Yes, I know now that my minor is going to be the square root of 112, and I'm sure that will reduce somewhat, but here's the little trick here for this guy. They want the equation for this, and so you don't really need to have this component. If you go back, because it's an x minor, your format for the equation looks like this. And I have minor squared straight up as a 112. I don't have to do any other math. My major squared, again, that was 11 squared, it's 121, and there you go, you're done. You don't need to find foci because they gave them to you. 10, 1, 31. So I don't like when they do this, but it will happen rarely. They talk about the major axis and the minor axis. Now, when they use the word axis with it, what they're really trying to say is 2 times your major. And so, say we had this, your major axis is this entire business here, okay? But what I'm saying is that my major is just that distance individually. And the same thing with this one. This is 2 times your minor. And so, this particular problem says that my major is equal to 20, and they also say that it's horizontal, which means that it's going to be an x value. And that's good to know. It looks like that, basically. My minor axis is equal to 16. So here, there's my equation. Solve for major and minor. You'll see that you get a 10 and an 8. So my major, my x major, because it's horizontal, is a 10. My y minor is an 8. And so with these, I can immediately go to my equation here and do this. And again, if you need to simplify it, because, well, you do in MyMathLab, it looks kind of like that. So there's your equation. That was pretty easy. We're just needing to understand on this problem when they say axis that they're meaning 2 times major, 2 times minor, the whole entire thing, rather than what I normally call it as major and minor, are individual distances. 10, 1, 6, 3. So I've got x squared over 9 plus y squared over 64 is equal to 1. And, so they got like a big curly thing that's a piecewise function, x equals 3. Now, this is a weird thing here, but this is going to be a y major, some kind of ellipse, and it has a vertical line, x equals 3, right here, and they're touching right at that point. And in fact, that point where they're touching is 3, 0, because again, x is definitely equal to 3. And what they're wanting is find the solution set, find out where they're intersecting. Right there. You don't have to do any math for this. I mean, I guess you could take this 3 and plug it in and blah, blah, blah. It doesn't matter. Regardless, that I don't even recommend it. Don't even do that. Just look at the graph here. You can see right there what's going on. 3, 0 is where they're touching. I'm just, there's sometimes weird problems, and so I wanted to make sure that you saw and understood what they're asking for. What are they asking for when they say solution set? They're saying where are they intersecting. Look at the graph, no problem. 10, 1, 69. So this is a really weird problem. There's this semi-ellipse tunnel, so it's some kind of a tunnel that, will go on here. Okay, something kind of like that, I guess. And there's a truck that's trying to fit through, and the truck is a big old rectangle, something kind of like this. Here, let's put some wheels on that thing. There you go, there's your truck. And he's traveling through. There's your front wheels and stuff. Guess he needs to be off the ground a little bit more. Regardless, got a big old truck. And we're wondering if this truck will fit inside of the tunnel. Will this truck fit inside there? What's going on is that essentially we have this semi-ellipse and we have a rectangle, and we're wanting to see if the rectangle fits inside of it. Are they touching? Are they not touching? What's going on with that? Okay, so that's essentially what's going on. Let me give you some dimensions. So they say that this full distance here is 48, and then my height is a 12. For the truck, we have an 11 height. So I'm gonna do the truck kind of separate. This is the truck. The truck has an 11 height, and it has a 14 width. Okay, and there's my wheels. You're just basically looking at the back end of it, basically. Okay, cool. So we have our dimensions, and I'm wondering, does it fit? Yes or no? Well, this is a semi-ellipse, and so you can see I have an x major, because that's going to be half of that is going to be 24, which is going to be my major. My minor is actually just a 12. You don't cut it in half because you can see that it would have another half down here, but we're only focused on the one distance, therefore your minor is just going to be that 12. Makes it kind of easier, and so we got x squared over 24 squared, and y squared over 12 squared is equal to 1. That's my equation. We're basically already done with it. If you really want it to be simplified, that's fine, but they don't need that because the question ultimately is, does it fit, not what is the equation. Okay, so this is what we're going to be working with here. That's a 144. Sorry that it's kind of sloppy. How do I know if this truck here fits inside of this? What do I do? What's that critical understanding, that concept? Well, if you notice right here, I can use one of the top corners, and if that top corner scrapes, then obviously it won't fit. This is going to be the most extreme point at which the truck will be touching anything. It won't, like, if it's going to touch, it's going to touch at one of these corners. And so how do I determine the corner? Well, again, it's centered at 0, 0, so this distance here is only a 7, yet it's still at a 11 height. And so my x value is going to be, here, xy, is going to be a 7 and then an 11. And I'm going to take that x and my y and plug them in, and actually I'm not going to plug them both in. Hold on. You could, and you could see if it's equal to 1, if it's actually literally touching the top, but I don't think you're going to get exactly that. The best way to do this is not to plug both of them in, but to plug one of them in and compare the y values. So here's the two options that we have. I either have the truck is on the inside and it's not touching. See how my y values are going to be different from one another there? The other option is that the truck is going to be like this. And notice that the y values are different again, but one is higher than the other. And so what I want to do is plug in the 7 and see the height of this semi-ellipse, and I'm going to compare it to the 11, okay? So plugging in the 7, we get a y value, blah, 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 lots of math, I'm not going to go through it all, of 11.4782 feet, okay? So that is the semi-ellipse height. And so what I'm looking at then is right here. This height right here is 11.47. The truck itself is only 11.0. And so does it fit? Yes, it fits. It's not this one, it's this one. Because my truck is 11, but the height of the ellipse is 11.47. So that's good. It has some clearance in there. What they're also going to want you to do, just to make sure that you actually did all this, is that you have to write in 2 decimal places the height, and I think that's maybe feet. And that's your second answer. So yes is your first answer, that number is your second answer, and that's it. That's all I got. So thank you very much, and have a great day.